Good morning, grade 9. Here with you, Ms. Randa Wahid. I'm your math teacher. Today with new lesson, which is in chapter 8, lesson 9.3, graphing quadratic function. We talked about quadratic function last sessions, and we knew how to get the vertex and how to get the line of symmetry and how to get the zeros of the function. If you remember, this is the vertex or the minimum point here and maximum point here. This is the vertex, it's 0 and 2, and here the vertex is 1.5 and 1.5. Okay, here x of symmetry is the y-axis, which is x equals 0. Here, this is the x of symmetry. Now, and the zeros of the function here, 1.5. The parabola meets the x-axis in 1.5 here, and negative 1.5 in the other side. And here, the zeros is the zero here is only 1 0, which is 2. Okay, so remember the last session lessons. Now we're going to get the y-intercept. If you remember, the y-intercept is the coordinate of the point where a graph intersects the y. Then the x-coordinate of this point always 0. For a quadratic function written in the form of y equal ax power 2 plus bx plus c, x equals 0, so y equals c. So my y-intercept is the c. My y-intercept is the c if my quadratic function is in this form or in general form. Okay? Okay. Let's see here. We get what? We get here the y-intercept. We are going to put the x is 0, and so y equals the c. C is here is negative 2. Okay, so down in negative 2, this is the parabola meets the y-axis or y-intercept. Parabola meets the y-axis in negative 2. And here, the parabola meets the y-axis in, here, look at the equation here. The c here is 4, so in 4. The parabola here meets the y-axis, which y-intercept, in negative 3. Very good. Okay, let's see here. He's telling me to graph a quadratic function. For graphing a quadratic function, you have 5 steps you must go on. So please concentrate with me and remember these steps carefully. Here's step number 1. I'm going to find the x of symmetry. What we said about x of symmetry last session, we get it from here. If I'm telling you to get the x of symmetry, so you must get a, which is the coefficient of x power 2, here a is 1, and b, which is the coefficient of x, here is negative 4. And I'm going to do what? X equal negative b over 2a. Negative b over 2a. Substitute, then the x equals 2. So the x of symmetry, x equals 2. Then we're going to find the vertex. The vertex. Okay, how to get the vertex? The vertex I have already, it's x here. The vertex is order pair, you remember? Order pair, which is x and y. My x, I already get it here. It's okay, I already get it from here. X equals 2. What about the y? The y, you're going to go to the y, the equation, your equation from here, and substitute it by 2. Substitute the x by 2. So you're going to find that y equals x here is 2. 2 power 2 minus 4 times 2 minus 5. So you will get it, negative 9. So your vertex is x. And y? X we get it from the step before, which is x of symmetry, 2, and we get here the vertex, the y coordinate, which is -9. Okay? Then the y-intercept. Now we said y-intercept, so put x equal 0, or if your equation in the form of ax power 2 plus bx plus c, so your c is the y-intercept. So my c here is -5. So my y-intercept is -5. Okay? Okay. The fourth step, what we're going to do, find 2 or more points on the same side of the x of symmetry. As the point contains y-intercept, since the x of symmetry is x equals 2, so write that you are going to draw it, x of symmetry x equal 2. Then we're going to put what? Equal 2, so I have 1 and -1. Okay, 1 and -1. Take these two values and find the y. So you have here 2 points, 1 and -8 as ordered pair, and -1 and 0. Then you're going to plot all what we get. We get what? 1, 2, 3, 4 things. You're going to draw the x of symmetry here. Look here by green. X equal 2. And the vertex, which we said 2 and -9. This is my vertex. Then the y-intercept, which the curve intersect the y-axis, here in -5. And the other 2 points that I get from here. Okay? I'm going to plot them, then draw the curve, then draw the curve. When drawing the curve, you will find this parabola. It's open where? Tell me. It's open upward. Remember? Open upward. Why? Because the coefficient of x power 2, the coefficient of x power 2 was positive. So it's open upward. Okay? Very good. Open upward. Very good. So you're going to draw a part here, and you complete the same to the other side. You're going to reflect the points across the x of symmetry, connect the points with the smooth curve. Okay, so I'm going to draw in one side, then plot the same points for in the other side. Okay, across the x of symmetry. Reflect these points. Reflect these points in the other side. Very good. Now you have exercise in page 62 in your practice book. We're going to solve it. First, I'm going to grab this function. So if I'm going to grab it, I must get first my a. My a is what? A here equals 1. It's a coefficient of x power 2. And b equals 4, which is coefficient of x. And c equals -4. -4. So my x of symmetry, do you remember? Negative b over 2a. Negative b over 2a, you will find it equal -4. Very nice. So my vertex, after this you're going to get your vertex. So you're going to put y equals. You're going to have my vertex is x and y. Remember, my vertex is x and y. My x, I already get it in the first step, which is -4. Now I want to get the y. How to get the y? I will substitute here in the equation, the quadratic function, by -4. So it's what? -4 power 2 plus, plus 4 times negative 4 minus 4. You will find that y is negative 8. So my y here is negative 8. Very nice. Y-intercept? What's the y-intercept? Here my c is y-intercept because it's in the general form or the quadratic function form. So here minus 4. Okay? Two other points we can use, which is 1 and 1 and 2 and 8. Okay, we can use this. It's in one side to the axis of symmetry. Okay, then we're going to plot all these points here. Try to solve the next problem and draw this curve. See you next session.